Yes,
Excuse
yes.
Yes.
me. All right. So pandas is a very important topic, and we will continue from where we left yesterday. And just to once again re-illustrate the context, what we are doing is beyond pandas. We are using pandas to do data analytics. So I wanted to give you a flavor of how basic data analytics happen. So we've already done a lot of parts of it. One of the biggest things really is first you got to clean the data. Till the time you do not sanitize the data, you cannot work with it. And we saw a lot of examples of it. We saw smaller examples when we were working with the stock data that just involved one or two interventions. But with the movie data, we are seeing that it is requiring intervention in practically every column, right? So that's what really happens with real data. And this is a data which has come from a public source like Kaggle. So that's the data cleaning part. Then you got to explore the data and figure out, what is the form and shape of data. For example, we figure out we see a lot of numbers, numeric values, but when we check the data type, they're actually strings. So that gives us that what we think or what our eyes think and mind think perceives, that may not be the actual data type of a particular object. So then we need to modify that as well. So we've done these data cleanings, data explorations. Then we went into defining the problem statement. Fine, you have a lot of information. You have, let's say, 5,000 rows and you have n number of columns. But what exactly is it that you are trying to find? Once you identify what is it that you want to solve, then you got to write an algorithm. Okay, this is what I want to achieve. I'm going to achieve it in 5 steps. In first step, I will do this. Okay, now within that first step, now you get into the micros of the step one, and you have to write individual steps which will lead to the desired outcome of step one. And then you go to step two, and that's how you build. So you get an idea of that because I want, more than pandas, I want you to get a understanding of how to develop an algorithm to solve a problem irrespective of domain. Physics, chemistry, economics, finance, that does not matter. Is this part clear?
Yes.
Yes.
Okay. Then I have already initiated yesterday's data. I think I have initiated. Let me just check once again. Okay, yes, I have initiated. So this time we are going to today we'll solve a problem, right? And tell me if this is a good problem to solve. Let us make a list of all the lead actors in our data set and find who are the most bankable actors in descending order. Okay, so since we're looking at a Hollywood movies data, actually it's an international movie data, but most of the movies happen to be Hollywood in English language. If we investigate the database, and we have a fairly sizable database of almost, I think, even in terms of sanitized database, you can see here we have about 4,800 records. So we have quite a lot of records in our database. So we are trying. So let's say if you're a movie producer, right? What does a producer care for? Producer is the one who's putting the movie and he's the one who's financing. So there are these production companies. What do they really care for? They will care about uh, a broad set of parameters, but within them, okay, fine, they have frozen the storyline, they have frozen the genre. Yesterday we saw how important is genre. You can have the best of actors, best of storyline, but if you're in the wrong genre, probably you will not find enough of resonance with the audience. So let's say as a producer, I've frozen the genre. Within the genre, I have got a very good storyline. What is my next problem? I want a bankable actor. There has to be a track record across multiple movies, which tells me that if I put X amount of money on an actor, right, I'm going to get probably 3x or 4x. Does that make sense?
Yes.
Yes.
Yeah. So we've already solved the problem of genre. So as a production company, I know, okay, you know what, I'm going to put my money in action. All right. Now I'm going to look for a nice, what do you call, script writer? No, sorry, not script writer, maybe a story writer. So I'll get a very nice script, right? I will do all the screenplay and everything. Now I want to cast. So we are going to solve the problem of casting. We've got a great context. Within that, who are the most encashable actors? Okay, so with that, let's look at movies one, cast. Let's see what do we get. This is not very readable, is it? It's not clean. They are not even separated properly. Can you really make out who are the individual actors here?
No.
Sorry, this looks. Okay. I also want to know. So this data type anyway should be string, but let's check. Yeah, it's a string data type. So first and foremost, let's say now you know that these are the names of actors in a particular record, which is associated with a particular movie, right? Now we want to see on a consolidated basis who are the most bankable actors. So first we should begin with having a list of all the actors. Don't you think so?
Yes.
We just spoke about an algorithm. If this is our end goal, right? One of the first steps should be that we should have a list of all the actors. Only then we can tabulate who earned how much against what budget. Okay. So I will say make a list of all lead actors. Okay, why am I saying lead actors? Okay, let's look at this record. Because a movie, this record, this is probably still one which has fewer. So there are movies which can have probably 5, 6, 10, 11, 12 different actors or actresses. We want to just concern with, let's say, top three. Is that fair? And we've all been consumers of movie. We've been audience. When we actually look at the cast, how many names do we actually read? Right? We don't really go beyond. We don't really look at too much of support cast. We look at the top 2 or 3 actors, and that forms an impression. Fair?
Yes.
Yes.
All lead actors. So we'll confine it to 3. Confine it to top 3 casts in any movie. All right. If that is the case, then let's make a container. We'll make a list container, actor list, where we'll capture the names of all the actors. Now, please feel free to contribute. Huh? We've seen a lot of these iterations yesterday. So whoever wants to contribute, please do contribute. I'm going to iterate over all of this. And to avoid any errors,
Can you scroll up a little, please?
yeah, sorry. Okay. We saw the problem yesterday when we were not using try. It will probably iterate through 2000 records and suddenly it will throw an attribute error or a value error and we'll get stuck. So let's try to avoid it today. Okay, so we will call item. What should item be?
Cast.
Individual records.
Yeah.
What should we do next? This is how you'll get that record. Okay, and it's a string object. Can we iterate over string object? And we saw yesterday that when we split this, all the individual components of the string
They will be separated.
in a list object. So this will transform into a list object, which is iterable. Okay. So what has just happened is we have broken this down. You see this record? Now it's contained in a list object and we can iterate over each of them individually. So this is now iterable. If this is iterable, and let's iterate over it. So for j in range 0 to length of item, and I want to hop by 2. Will anybody tell me why should I hop by 2?
Because the name has been split. So that's a single name.
Yes. And we have to iterate till the time actually the second condition should also fulfill. Okay, please tell me why should we do this? Algorithm is all about logic, right? You can code anything here. Why should we be doing this? Just think. So I'm giving you one hint. Every name will have a first name and a last name, right? Which will be 2 iterations of j. So why are we doing this? Why are we iterating up till 1 less than the length of item? Okay, we are doing this because let's say if the total length is about 9, we got 8, right? It will iterate. Now j is equal to j has already covered 0. Let's say there are 9 items and 8 will represent 4 pairs of name, right? Then it will look for another 2 and it will not find, and it will give us an index error. You follow that? If the total length is 9, right, it will come to the 9 and it will again look for 2 places, 2 index values to capture the next name, because every name is capturing 2 different index values here or 2 different iteration values here. So if you have only 9, the length is 9 and it is coming up till 8, it has already captured 4 names, first 2, then 3, 4, 5, 6, 7, 8. Then it will look for 2 more and it will not find 2. So we are confining it to 1 less. Is this clear?
Yeah, got it.
Sometimes what happens is that maybe you don't do this minus. You do this, you will get an error. When you investigate your error, then you will realize, okay, what is the way to make my error get away? And then you make your error get away. And the way to do these kind of long things is first start small. So right now it is going to iterate over the whole thing. But you know what? You want to just do an early test. What you can do is you can just go up to 3. Because if your problem, in first 3, see whether this is working. If it is working, then you carry on. Okay, so I'm going to remove this for the time being. So we are capturing the top 3 actors. Okay, what should be the next step? So I'm creating, okay, I need to create a container here. Because okay, somebody please tell me what are we doing so far?
We're trying to make a list of all the lead actors. So first we're going to iterate it, and then
Fair,
if it's
fair
in the
enough.
room,
Yeah, but tell me what are we iterating over?
which is like the list of movies and the cast.
Okay, so we are going through
We're
each
doing
and
that.
every record in our database, and here we are going through each and every record of cast, row wise, right? Every row represents a lot of information, but we are only concerned with cast associated with that record. Okay, that is what is happening here. Now, when we are into a particular record like this, what do we want to do?
We want to remove the unwanted
What
names.
is unwanted? Which are the names which are unwanted here? These are all actor names.
Yeah, but there is some UOOE. But we don't want to clean this.
Yeah, but what is the cleaning required? Please define.
Basically, we are wanting to take out the top actors, name of top actors,
What is top?
top four, top grossing actors, cast.
Top three.
Top three, sorry. Top
Okay.
three lead actors. Yeah.
Fine. So we are in the movies one cast column. We are in the very first row.
Hmm.
Okay.
Yeah.
What are we doing? What have we done so far? Let's say we are in the very first row, and let's say the very first row is this. The 0th row is this. What do you want to do with it?
So it will start iterating from Johnny and it'll
Before iteration, what do you want to do? This is a string object.
split them.
Okay,
Create
so you split and you got a list object.
list object, yes.
Okay, what do you want to do in the list object now?
In the list object, we want to go through the length of those objects, hopping 2 steps.
And what do you do? Okay, so fine, you're doing this here,
Yeah.
right? And you put a condition.
Yeah.
Then what do you want to do next?
Now we want the top 3 actors.
How will you do that?
I think that's the condition. Just iterate it once. And if it isn't that, just print it.
Fair enough. If it is in this, what do you want to do? It is iterating over the list of actors in a particular record. Let's talk about the 0th record. And let's assume this is our record, right? Starting with Johnny Depp and ending here at Yun Fat. You want to capture the top 3 actors, which will be Johnny Depp, Orlando Bloom, and Keira Knightley. How will you do that?
So if they are in 0, 1, 2, 3, 4, then we need to print them.
We need
Indexing.
to print them. What are we going to do with printing? What will we achieve? I thought we were trying to make a container list of all the actors without any duplications. Because one actor could have acted in 10 different movies, 20 different movies.
Yeah. Okay.
Whatever coding we'll do, you will know it because we've done enough of it. So now it is beyond coding. You have to think of the logic. What are we trying to do at this step? So I'm going to create a subcontainer here because I want to capture the records of this movie. Right? I'm already in the first record. Now I'm iterating over this list. And then
I'm going to put all the 3 lead actors in that subcontainer.
how will I do?
Append, yes.
What should I append?
J.
J what? We should append J?
If the condition is met, is
That's fine.
J.
But
Yeah.
how is that J helping? Is J the name of an actor?
No.
Then
Cast. No.
So what should we do here? You want to capture the name of?
First, lead 3 actors.
So what do we append here? What is this movie actors container? What is the difference between this container, actor list, and movie actors?
Actor list has all the names.
Okay, and movie actors?
Movie actors is a container we have created to put in 3 lead actors.
Which 3 lead actors?
The top 3 lead actors.
Which
That-
top 3 lead actors?
The one we are trying to find out
Find out from where?
from the actor list.
No.
From the cast, sorry, from the cast.
Again, wrong. Cast and actors are the same.
Okay.
This is going to be a universal list of all the actors without any duplication. All the actors who have been in the top 3 actors in all the movies in our record will be captured in actor list. An actor list should not have any duplication. But for each and every record as we iterate, we need to call out those 3 actors. Okay, why do we need to call out those 3 actors? Because we want to replace this row. Otherwise, in your database, movies cast, every row will still appear like this. You will make an actor list, but this record will keep looking like this. Eventually, if you have to do sorting in a descending order of their bankability, you will have to go back to this data frame. How will you play with this data frame if you are not able to arrange them properly? Okay, now I want to append it to actor list. Should I give any condition before appending it? Have you understood what has happened here? I'm appending the first name here, which is for this particular record. Why have I created this container? Why have I created move underscore actors or rather movie underscore actors? Because this will replace this string. Understood?
Yes.
This is specific to a record. And this is overall. This is specific to a record. I want this list to replace this string for each and every movie cast record. Okay. Now, okay, fine. I have appended. As it is going through and satisfying this condition, as J is iterating, it will keep on appending and capture the top 3 actors for this record. Right? Now, those top 3 actors need to be appended in actor list also. So should we be checking anything before appending? We don't want any duplication. Is this clear?
Yeah.
Yes.
Always write down the logic first, the algorithm first. So guys, this is the real deal, right? Following individual syntaxes, what does NP-way do, right? This modulus, that floor, or making even a list of lists, that is not going to solve any real world problem. This is where we are dealing with real life data. And we are trying to do some meaningful stuff. And this takes logic. It's okay. It comes with practice, so it's okay. But what I'm trying to emphasize is keep thinking more in terms of algorithm, which is logic, the step-by-step process. Coding can follow. If you forget a syntax, it's not a problem. You can go back and refer. But there is no reference book for logic. So we have taken care of duplication. Okay. Now we have captured the top 3 actors of this record, the first record in this container. Right? Now I want to replace this here in the data frame. How should I replace? And look at the indentation. I should replace only after the J for loop is over, correct?
Yeah.
It cannot. So please remember, this cannot be here. This cannot be here. And I would encourage you to do it, right? Just play with top 2 or 3 records and change the indentation of this container or rather this data frame record, right? And see what you're getting. That's when you'll understand. In fact, it's going to become more clear when you do that. That's why so logically, only when it has captured all the records, which will happen when J has completed its iteration, will this container be full. When it says full, that is when I will use it. This is for iloc I. What should I put here? Except attribute error. If I get an attribute error, please continue.
Just want to clarify, what have we done over here? Why are we doing movies, one cast, iLoc?
You tell me. What is the problem statement?
The problem statement was that we need to make the list of all 3 top actors.
No, that is not the overall problem statement. What is the overall
All lead actors who were most profitable, bankable.
Okay. So for that, what are you trying to do?
So we are first taking out the name of actors all from the cast.
Okay. Record by record.
Yeah.
Okay.
Then we make the list of all lead actors, but we're taking out the top 3.
Okay. From every record.
Yes.
Okay.
Okay, then we're trying to put it back in the record,
Which record?
in the original record.
This.
Yeah.
Okay. So have we done that?
Yeah, okay.
Are we doing that?
Movies, cast, iLoc, we want to put it back there.
Yes, we are trying to replace
Yeah.
this string with a clean, sanitized list of top 3 actors
Got it.
captured in this container. Okay. So before I modify my data, I want to print it out. and see that I'm getting it right. Movie actors, actor list. Okay. So let's see till the end. List. Where did this happen? List index out of range. Okay. I'm going to do one more thing. Let's print so that we know where did we get this error. I'm going to print J as well. Sorry, not J. I'm going to print I. Okay, I'm going to print I right at the beginning. So we are getting a problem in this record, 4606. List index out of range. Out of range. Movies after the pen. Okay, J under 6. Okay. We removed -1. Remember we discussed this?
Yeah.
Let's see if
Yes.
it works now. So you see what happened? It would
Yeah.
have hit an odd number in the length and it wouldn't have found 2 more records. Got it?
Got it.
So now that this is working, right? See, so did you understand why I hashed it out? Because if we were making any error, which we did, it would have modified our original data. So I want to make sure that this works before I modify my data. Now let's do this. And see, okay, I don't need I. We're printing out anything else. We're printing out something, okay. Okay, let's look at my length of actor list. That is what we are capturing as the overall record. Oh, so we have 6,200 actors, 62. Okay. Let's see if this has worked out fine. This is arranged nicely now.
Yeah.
Okay, let's save it. What should we do next? You all remember the original problem statement. Okay, so I'm going to help you out. We will create a separate data frame. Let's say an empty data frame for actors with 3 information, right? Actually, we primarily are interested in 3 information. What are those 3 information? Budget associated with him or her,
Yeah.
revenue, and
Yeah.
number of movies that he or she has done, right?
Yes.
So I will create this. So what should be the index values here? Please remember, these are not the column values. These I'm creating the index values, and we'll see in a second. These are named index values or named or row names.
So, budget, revenue, movies.
Okay, fine. Where? These are rows or indexes. But we have to put column names, right? What should be the column names? Names of all the actors,
Factors, yes.
right? So how do we populate that? Should be simple, right? This has list of all the actors. How do we create columns? Columns in a data frame, we discussed this. And I have to
CO,
define it as a PD series, Panda series. Did you follow this? Oh. What happened? Clear? Did you follow so far?
yes, yes.
So we went over this actor list, took up every item one by one, which is the name of an actor, right? In our data frame, we created a column for that actor like this, and each column is a PD series. Now, this is all having NaN values because we've not given any values. So let's initialize by giving them a 0 value. So now I want to iterate over this data frame. So what are we trying to do? We are trying to replace all of these with zeros. Why? Because eventually we want to add. We will go through every movie record, and if this actor was there, right, I will add the revenue associated with that movie here. Similarly, budget here. Similarly, movies here. So for me to be able to do a mathematical operation, I must have a integer here, integer or a float, numeric value. We can't have NaN, right? Did you understand this?
Yes.
So I'm going to replace all this NaN with 0. So there are multiple ways of doing this. I'm doing this. What will I do? Actors. I've selected the column, the name of the actor. Then I have to select the index value, row name, lock equal to 0. Is this clear?
Yeah.
Why have
Yes.
we used lock revenue? Clear?
Yes.
So it's now going each and every column wise. First, it will go for Sam Worthington. It will replace all of these values. Then Zoe Saldana and all the way till the end. Okay, so that's taking some time. Okay, while this is taking some time, we can at least write some code. So we are dealing with a very big database which has a lot of columns, but our columns of interest are, we'll subset this. What are our columns of interest? What are the columns that we are interested in?
Revenue, budget, and movies.
So eventually, right, we will iterate and we will fill up movie record by movie record. But when we are finally trying to capture all the statistics, right, we want to know the cast and what are the budget and revenue associated with that cast. The name of the movie doesn't matter, but the number of movies will get captured. For that, we will write another small block of code. So here we are just subsetting, and let's just take a look at this. This is not going to run till the time the upper one gets through. So in the meantime, can we modify this and make the budget and revenue in million? We did that yesterday.
Yeah.
So what should I do? I'm only out of this smaller data frame, I'm only selecting two columns, which are numeric, which have large values. And I want to convert them into millions. Key actors. Now what? Apply. Now, lambda. Then,
X upon 1 million. Yes.
boy, this is really taking time. Why is it taking so long? Okay, I want to make sure that this is not stuck in some kind of an endless loop. So what I will do is, let's see if this is working at every step. Actors dot head one, only one record. No. Okay. Print this out. Okay, so it's happening. Wait, let me do something else. So we interrupt the kernel. Let's take whether it's happening, what we are expecting to happen at every step. Okay, actors dot column one. Actors dot call. Yes, it's happening, right?
Yes, it's
So
going zero.
code is working, but it's working very, very slow. So now I'm going to interrupt. Hush it out. So in the meantime, I'm assuming that you at least have a laptop. If not, paper, pencil. Please sketch out the algorithm, write down whatever we have done so far and what remains to be done. I want to know from you, what are the next steps we should perform to complete our original objective. You remember the original problem statement? Any doubt about the original problem statement? Okay, is somebody going to tell me what is the problem statement? What are we trying to do?
We're trying to find the budget and revenue and the like the movies the actors have been in.
How do you want to see that information? We created a data frame for that, right?
Yeah.
Like this. So you want to see all the information captured in this data frame, right? With what was the revenue, budget, and movies associated with every single actor in our list, right? So this is the objective. Write down whatever we have done so far and what would you do next. Coding we can worry about later. But tell me what is the next operation that we should perform.
We need to find out if revenue exceeds budget.
Where was that condition?
No.
We are only trying to find all this information.
Okay, yes, yeah. We want to fill this information.
So what should we do next? So you have to think of the next step to be able to do the next step.
We need to find the budget and revenue associated with each actor. The movie, sorry, the movie.
Yes. So the next step is populating this. In the current step, we are only assigning a value of 0 so that we can perform mathematical operation on this, which will be addition. We will go through each and every movie record if this actor is there in that movie, right? We will add whatever was the revenue budget to that. For that, we need to have a numeric value, right? Okay, so this, for whatever reason, seems to be taking longer than I thought it should. So let's just park it here. Okay, finally this worked. Okay, we will come back to the class and object. So let's do a subcategory of this. This is what we get, right? Now we are trying to convert these figures into millions. This is more readable. So did anybody come up with what is the next step? I think we already agreed. Now here is one challenge. And for that, we don't have an answer in this data. Can I link a specific revenue to Sam Worthington? No, I'm not able to, because that movie did so much of revenue. I cannot say how much of that revenue is linked to this. Okay, I can get an idea if I knew that out of the budget, what percentage of the budget went to Sam, to Zoe, and to Sigourney. If I knew that, okay, let's say this guy got, let's say 20% of the budget, this guy gets 15% and she gets 10%, then I will proportionately link the revenue also to them. So right now what we are doing is, wherever, let's say Sam Worthington is there, whatever was the movie and revenue, I'll keep on adding to his record. That is the only way we can do it. So I'm saying that, okay, not that Sam in his individual capacity produced that kind of a revenue, but what we are trying to find out is what was the total budget of movies where Sam Worthington was cast, and against that total budget, what was the total revenue? Do you follow this?
Yeah.
That impact cannot be individually associated, but what we're saying is, okay, let's find out whether this can give us any bankability. It can't just be a fluke if you're going through so many records that, okay, you know what, Johnny Depp along with two other people, right? And those other two people can differ from one movie to another, but Johnny Depp is a constant in the movies where he has starred. Let's say if he acts in 20 movies and those 20 movies had a cumulative budget of X and a revenue of, let's say, 3 odd X. I'm not saying that Johnny Depp individually did that, but it can't be a fluke that, okay, he's in 20 odd movies and whatever was the outcome, good or bad, he had no impact in. So he would, and it would vary from actor to actor, right? If an actor is not really making an impact, then it will eventually average out over multiple records. If an actor has acted in 20 movies and in one movie, it's showing it's a mega hit, but that actor did not really have an impact, then that will show up in other 19 movies somewhere. And it will overall at a consolidated basis, it will reflect in the revenue associated with that actor. Clear so far?
Yeah.
Yes.
Okay, let's save and let's do the final step. So you told me that we need to find now all this information. So what should I do? We have created a mini data frame of key actors, only the information that is relevant to us. So I will, for each and every record, right? See, okay. I'm just simple. I'm giving these abbreviations. I'm creating these variables, but for budget for that particular movie record. Then we will capture the revenue for a specific movie record. And the cast for that record. Now we are going movie record by movie record. Is there another way of doing this? See, we could have taken each and every actor from our actor list. And for every actor, we could have gone through all the movie records and seen wherever that actor is cast, we pick up that information. Do you think that is going to be more efficient? Or we go movie record by movie record and we see who were the cast in a particular record, and whoever were the cast, we pull out the information and we plant that information in our data frame. Think about it.
Going to actors would be lesser number of steps.
Why? How many
Because-
will you have to go through?
Because
How many actors do we have?
3.
No,
Top 3.
we're not. We are iterating over this
Okay.
entire list.
Okay,
62,
okay.
62.
Yeah.
So we'll pick up every single actor, and for every single actor, we'll have to go through 4,800 movie records.
Yeah.
So how many loops are we going to do? 62 into 4,800.
No, then we go to the movies and then.
So we'll just go to the movie record. So this is again part of your algorithmic thinking. How do you reduce the overload on your code and you make your code more efficient? Programming is not learning syntax. It's learning to solve a problem in the most efficient way by using a structured logical process. Okay, now I have the cast. Okay, I can only use this cast. You remember now this cast is all a list object. Correct? We have captured the names of the top 3 actors in a list for each and every record. So I want to make sure that before I perform any operation of this is actually a list object, because we can't investigate all 4,800 records. So I'm saying if is instance, if this cast is a list object, what is it asking? If this variable, this object cast is a list object, okay, only then perform the following operation. For actor in cast, what is the next step? This actor should be part of our data frame, right?
Yeah.
If he is there, then what do we do?
Append.
Correct, we simply add his information. Actors, actor, what should be here? Revenue. What should be here? Think about this carefully. Why?
Rev. Yes.
Why is it plus equal to rev?
If it's more than or equal.
What has it got to do with more than and equal to? Every single record where a given actor is there, right? We want to know the cumulative revenues. It will keep on adding to the previous entry. You understanding that?
Yes, it's going to keep on adding to the revenue.
Yeah, we want the cumulative number.
Yeah.
Wherever Johnny Depp was, if Johnny Depp was in 20 movies, then for each and every movie record where Johnny Depp was, I want to add that value to the value which is already existing. Because we want a sum total. Why is it 1? Because every time an actor is in a movie, right, we increase the number of movies by 1. Clear?
Yeah.
You think this is going to work? So what are we doing here? Check if object finally we do have. Okay. But we have one more problem here. Will somebody tell me? It's not sorted. So we'll create actors sorted. We want it in descending order, right?
Right.
Actors dot sort values. What do we want to sort on? Let's sort by revenue. You want to know the bankability, right? Revenue axis equal to 1. So the columns need to be rearranged based on revenue. And it has to be descending. So we will say descending equal to false, right? Is clear? What are we trying to do here?
Yeah.
So actors sort values by revenue. Now this sorted. See the list changes.
Tom
We have
Cruise.
Tom Cruise on an average, whichever movie he's associated with, it generates 4 times the budget value and revenue. But Robert Downey is even better, right? If you take a ratio, I think this will be more than 4, and this is under 4. So Robert Downey Jr. produces more than 4 times the return. What about Johnny Depp? Johnny Depp is less than 3 times. Then this guy, I can't 1700. That's 34, 68. Oh, this is very good. It's more than 4.5. Actually, he's better than Robert Downey. I'm looking at revenue over budget ratio, right? For every dollar that this guy is linked with, what is the return he produces? So this is helpful, right?
Yeah.
So whenever you guys are next producing any movie, this is going to be helpful to you. You would thank yourself that you learned pandas and Python. So was this good?
Yes, this is nice.
And so the good thing about data science is that also it gives you a lot of unbiased facts, database facts. So if I were to generally ask you, who do you think would be a more bankable actor, Ian McKellen or Brad Pitt? Normally because we've heard more of Brad Pitt and we know that he's a very successful star, we will say Brad Pitt. What are the figures which tell us? Brad Pitt just produces about 3 times. This guy produces more than 4 times, right? About more than 4.5 times. So you see the value of data and data science?
Yeah.
All right, cool. It also tells us something very interesting here. We have so many names in our list, right? Not everything is printed here. But let's say as we are going deeper and deeper, a lot of these people, I don't know why are we getting zeros here. That needs to be investigated. Why did we get zeros here? Can you think of a logic as to why are we getting zeros here? Because if they were even in one movie, that figure should have appeared here. Okay, maybe that we'll investigate some other time. So was this exercise helpful? This is how you do data analytics. Okay, so back
Yes.
to, so you will have to, of course, go back and refer to this again. I'm going to share the HTML file. But as we went through the whole process of figuring out and descending on a list of most bankable actors and 3 sets of information, revenue, budget, and movies, did you follow every step, every process?
Yes.
Yeah.
Yeah. Okay, fine. So we're going to just save this. Let's